So we're going to complete the 3 questions on the screen. The first one says we want to simplify this and answer it with positive exponents only. So the rule is when we have a power to a power, we multiply. So the negative for the exponent doesn't make the number negative. What it kind of really does is typically makes it really small. But for power to power, we multiply. So negative 3 times negative 4 is a positive 12. So we'll rewrite this with the x to the 12. And then for the y's, we have a y to the 3 to the negative 4. So 3 times negative 4 is a negative 12. And that gives us y to the negative 12 power. We want to write this with only positive exponents. So we take the y and we flip it over where it is on the fraction, so it brings it to the top. So this is really going to be x to the 12th, y to the 12th. And if it was negative on the top, let's say it was x to the negative 6 was our answer, then we could rewrite this to be 1 over x to the 6th power. So the negative exponent doesn't make it negative, it just changes where it is on the fraction. On the next one, we want to rewrite this in standard form, not scientific form. So the 11 tells us how many numbers we need to have after the decimal. So right now, we can see there's 4 right there. So I'm going to rewrite this as 1, 5, 1, 7, 2. There's 4 numbers there after the first one. So we're going to put enough zeros on there to make until we get 11. So we have 4. So this would be 5, 6, 7, 8, 9, 10, and 11. And then we can go back and put our commas if we want to. This last one has a few steps to it. For us to add or subtract square roots, they got to have the same stuff inside of it. So we can break down the square root of 28. We can't take the square root of 28, and what I mean by that is it would give us an irrational number, but we can try to simplify it. So the square root of 28, 2 numbers that multiply to be 28 are going to be 7 and 4. So I'm just going to rewrite this at the moment. And then for the 63, 2 numbers that multiply up to be 63 are 9 and 7. Now, if we can take the square root of a number, and when I say if we can take the square root of it, we would come up with an integer. Then we would do so. So the square root of 4 is actually 2, so I'm going to put a 2 here. And the square root of 9 is a real 3. And so I'm going to rewrite the rest of it. So we still got a square root of 7. Still got that square root of x. The square root of x over here. The square root of 7. And we got this 2. Or, sorry, we got this 6. We can't simplify this anymore because 7 and 7 are both primes. We can't break that down. But we can do 6 times 2, which is 12. And that's going to give us 12 square root of 7x, because I'm just going to put them back underneath the same thing. And then plus 3 times the square root of 7x. And we can add these now, since they both have a square root of 7x. Those are both the same, so we can add them and get 15 square root of 7x. And if you have any kind of questions, ask your math teacher.